you need 92.4 at the beginning. But if you're going to use miles at the end, you need 96.6 na variable here. So there are two possible formula that you could use depending on the unit that you're going to use, if it is metric or if it is English system. Okay. Next, we have different type of miscellaneous noises. So one is atmospheric noise. Anyone from the group who could discuss to me what is atmospheric noise? Anyone from the group? Mr. Orpiano.
Gatchalian po, sir.
Gatchalian. Yes, Mr. Gatchalian.
So, yung atmospheric noise po ay yun po yung radio noise na nagkakos ng natural atmospheric noise. So, normally yun po yung lightning discharges sa mga thunderstorm.
Okay, so when we talk about atmospheric noise, these are the normal noises that we could occur in the atmosphere. So since we have clouds all over the area, so yung clouds kasi there are charges at lightning charges kasi di ba pag kumidlat, there are different charges na kumakalat. So normally dun sa mga ano natin, mga clouds natin, meron yung mga lightning charges na tinatawag natin. So it will cause miscellaneous noise on your signals. So normally pag tumatama doon yung ating mga excuse me, tumatama din yung signal natin, nagkakaroon tayo ng or nadadala ng signal natin yung mga charges na yon at ito po ay sumasama doon sa receiver end. So that is what we call the atmospheric noise. It is a radio noise caused by a natural atmospheric process, primarily lightning discharge in thunderstorm. It is mainly caused by cloud-to-ground flashes as the current is much stronger than the cloud-to-cloud flashes. So, lalo na daw yung mga yung mga bumababang tawag doon kidlat, mas malakas yung charges na na-discharge niya doon sa area. Kaya excuse me, kaya tayo nagkakaroon ng atmospheric noise at that area. So the atmospheric noise here is the formula for atmospheric noise is equal to 65.5 plus En minus 20 log of your frequency. Itong En na to is yung atmospheric noise at a certain area. So given normally ito, na ibinibigay po ito. So this is a, okay? So the last parameter that we have is what we call the isotropic level, received level. So anyone who could discuss this? Anyone? Anyone who could discuss what is atmospheric received level? Mr. Orpiano? Mr. Orpiano? Mr. Rico? Mr. Sabariaga? Mr. Sabariaga?
Yung in-expect po na parang power level na nanggagaling po sa na binato mula sa transmitter.
Are you sure it is that?
Um,
Is that the isotropic received level na tinatawag? When we talk about isotropic isotropic, what we call what we mean by that?
yung equally na nagpo-propagate po ng equally sa
Ano yung equally? What do you mean by equally?
yung equally in all direction po
magpo-propagate po. What do you mean by equally propagating at all direction? What is that?
Pag nag-propagate po pag nag-propagate
ano nga yung pinopropagate? Iho? What do you mean by that? Ano yun? Ano yung pinopropagate?
Yung signal po na
ano yung nagpo-propagate?
transmitter po.
Transmitter. Are you sure? The transmitter propagate the signal. Are you sure? Are
Antenna
you
po.
sure, Mr. Sabariaga? The antenna. Oh, so what do you mean by that? The antenna that is propagating
In all direction with ano po,
signal with
equal
all direction equally. So yun yung
isotropic po.
isotropic antenna. So when we talk about isotropic antenna, we are talking about a theoretical antenna. So this is not a true type of antenna. No, there is no such an antenna that can propagate equally at all sides. So omnidirectional, meaning ng omnidirectional, meaning at all sides, they are propagating the signal with the same signal level. So normally, wala pong ganon. So when we talk about isotropic receive level, this is the power level. This is a theoretical power level wherein sinasabi natin na pag dumating dito sa kabilang dulo yung signal, ito po yung lalabas na signal level na meron tayo. So normally, when we talk about isotropic receive signal level, we talk about the unit of dBW. So when we talk about that, the formula that we're going to use is effective isotropic receive power in dBW minus your free space loss in dB. Parang nangyayari dito, you subtracted the free space loss that occur in the path to your effective isotropic power of your signal. So yun yung ano natin, yun yung kinukuha natin. And this is the formula for isotropic receive level natin. This is just a what we call this, theoretical power na nare-receive ng signal mo pag ibinalibag doon ng transmitter dun sa kabilang dulo. Okay? So next we have here the different parameters that you're going to do on your receiver side. So can we call somebody who could identify what are the different parameters that we could use? At least we have at least 7 parameters, I think. Can somebody identify the different? We have already 3 here. So they could identify 4 more. Anyone from the group? Ms. Fernandez?
Sir, yung receiver antenna gain po, yun po yung...
Wait lang anak. I am talking only just give me the parameters, yung 7 parameters that we're going to use in order for us to compute the parameters of the receiver area. Tatlo na yung nakalabas dyan. So, the receive antenna level, antenna gain, the receiver transmission line loss, the net path loss, ano pa yung apat pa yata yan. Okay, can you tell me other than these 3?
Sir, kasama po ba yung fade margin?
Fade margin, yes, fade margin is there. What else?
Yung kasama rin po carrier to noise.
Carrier to noise. So this is another thing that you're going to compute on the receiver parameter to know how much noise ratio that you have from your received signal. So meaning to say, kasi di ba sabi ko sa inyo, nasasama ng halimbawa nagpadala tayo ng signal from transmitter to the receiver. Dun sa mismo sa path area, we have atmospheric noises, and there sasama siya dun sa signal. So nagkakaroon ng miscellaneous noise, yung tinatawag nating signal na ibinabalibag at nare-receive ito sa receiver end. So at the carrier to noise level, this signal is computed how much noise meron dun sa signal natin. So nakikita yon, di ba meron na kayong anong tawag dito? Meron na kayong signal and spectra. 'Di ba normally yung signal nyo is makinis, yung sine wave. So yung spike dun sa natin sa signal mo, yun yung mga noise na kasama. So dun mo nakikita ngayon yung signal to noise ratio na meron kayo sa signal. Okay, so that's good. Any other, Mr. Fernandez? So you have paid margin, you have carrier, signal to carrier noise, we have antenna gain, we have transmission line loss, we have net path loss, and what else? Any other?
Hindi ko na po alam yung isa.
Dalawa pa, anak.
Ay, dalawa pa po.
Any other from the group? No, yes, Mr. Polarantino. Selectivity o sensitivity? Sensitivity. So sa sensitivity, when we talk about the sensitivity of the system is the gaano ka-sensitive yung system natin na makapag-produce or maibalik yung signal na ipinadala from one point to another. So that's one. Another. What else? Other than that, Mr. Polentino? Signal fidelity. I think it's another ano na lang. This is another characteristic na lang ng ano natin. Any other pa? Dynamic range. This is just the ranging of your what do you call this one? Yung range ng kaya ng system mo. Normally ipinapadala ito sa sa transmitter, not in the receiver end. Anyway, okay, pero that's good. So any other? Paid factor. Paid factor is the same as paid margin. Okay? Chip factor, that's another characteristic of the system na lang, anak. Okay? So that's good. Any other who could tell me? None at all. So let's proceed to the discussion. So we have here the different receiver parameters. One is the receiver antenna gain. So whatever formula that you got for your system. So ganito kasi yan, anak. Yung signal natin, wait lang. So you have here from the other side, you have the transmitter. So we have here yung we have here your first signal natin. Here, this is the transmitter side, and this is the receiver side of your signal. So receiver, transmitter, and then the receiver side. So pag pinadala natin yung signal there, going there, so you have here the transmitter power and the transmitter gain. So again, if you're here, you also have here the received power and the received gain. So kung ano yung formulang ginamit natin dito sa transmitter para sa power, ganun din po yung formulang gagamitin nyo dun sa receiver end. At ganun din po yung ginagamit nating formula for the gain of your receiver gain. So yung dalawang ito kailangan, because from here, guys, kung papansin ninyo, magre-receive ka muna ng signal. So whatever is the receive here will be itataas ng antena nyo. Papataasin ng antena nyo whatever yung na-receive na signal galing sa FSL mo or galing dun sa path mo. So from there, ladaan na naman ito sa transmission line kasi gagamit ka na naman ng kable papunta dun sa receiver end mo. So yun yung nakukuha natin. So kung mapapansin nyo, anak, kung ano man yung nangyari dito, ganun din yung nangyari dito, baliktad lang. So you have your antenna gain here from the receiver and then your transmission line loss. Again, ano-ano yung pwedeng maging transmission line losses nyo dito? The total line loss could be the attenuation of your cable, your connector loss, your coupler loss. Yun yung tatlo na normally meron dito. Tandaan nyo, you have at least 2 connector losses pag gumagamit or nagko-configure kayo kasi meron ka dito sa antenna at meron kayo doon sa transmitter. Another is what we call the net path loss. So net path loss, this is the total losses occurring on the system. So in general solution, the net path loss in dB is the total loss minus the total gain. So kung ano daw yung mga total losses mo dun sa system, isusubtract mo lang yun dun sa total gain na meron ka. So normally, ang mga losses na meron tayo sa system ay yung transmission line loss, yung receiver loss, at saka yung FSL natin or pre-space losses natin. Kung pabansin ninyo, lahat ito dapat in dB. Wait lang, merong ano. Okay, kung papansin niyo anak, sabi ko nga kanina, all of it is in dB. Nakikita anak? Guys, nakikita nyo? Hindi, nawala.
Nawala po.
Okay, wait lang. Balik natin. Okay. So, ayan. Kung papansin niyo lahat dito anak, all you need to do is add all the add ito, addition ito anak ito. Your transmission line loss plus your pre-space loss plus your transmission loss. Receiver losses natin subtracted by your gain yung transmitter at saka plus yung gain ng yung receiver mo. So these are the different losses combined subtracted by your all the gains on your system. So lahat po yan. So this is the formula that you're going to use. In general, total losses minus your total gain. But pag inano natin to, isa-isahin natin, you have your transmission line loss, your FSL or pre-space losses, you have your receiver losses subtracted by your gain sa transmitter at saka gain sa receiver antenna. So this is yan. Okay? So the receiver parameter, we have what we call the received signal level. The received signal level is the strength of the signal produced by a radio transmitter at a particular location, usually expressed in microvolts or millivolts per meter of the effective receiving antenna height. So, but here, we're going to use the formula for power in dB. So, either we have two ways on how you're going to solve for received signal level. One is in terms of net power and net path loss, and the other one is in paid margin and improvement threshold na tinatawag. So, in the first formula, received signal level in the dBW, dalawa lang naman ito anak. It's either your power is in dB watt or in dB milliwatt. Depende lang po dun sa reference point ng power nyo. Kung ang power nyo ay ang reference point ay 1 milliwatt, so this is in dBm. But if your power is in a reference of 1 watt, so this is in dBW. So here, in dBW, your output power must be in dBW subtracted by your NPL. Okay? Or the net path loss na tinatawag. So you just subtract your power to all the losses that occur in the system plus the gain on the system. So yun lang yun. Kasi yung NPL natin, sabi ko nga sa inyo, the total loss minus the total gain. That's it. Or if you're going to use the reference of dBm in your power, you just have to subtract it by your net path loss in dB. Tandaan nyo anak ha, dBm minus dB is in dBm. Tandaan nyo ha, dBm minus in dB is in dBm. dBW minus in dB, that will be dBW. Okay? Decibels in watts. Okay? Or you could just have here the next formula that is in terms of paid margin and improvement threshold. Mamaya papag-usapan natin yung paid margin and improvement threshold na sinasabi. So, received signal level in dBW is equals to paid margin in dB plus improvement threshold in dB. O, tingnan nyo ito ha, anak ha. dB plus dB, dBW. Okay? Here, nawala. Wait lang, nawala anak. Mali yung napindot ko. Okay, ulitin ko doon sa ano natin. dB plus dB is dBW. And if you have dB plus dBm, that is dBm. Tingnan nyo yung ano ha, yung mga binibigay na ano ha, na formula. Baka magkamali kayo sa unit. Okay? dB plus dB is dBW, dB plus dBm is in dBm. Okay? So, this is the paid margin in dB plus the improvement threshold in dB. So, that will be dBW. If you're going to use a paid margin in dB plus improvement threshold in dBm, you're going to get a dBm unit for received signal level. Next, we have here the noise threshold. When we talk about the noise threshold, we are always talking about kung gaanong noise lang ang kayang tanggalin nung receiver end natin. So threshold, kaya nga natin tinatawag na threshold ito. Ito hanggang dito lang. Kung halimbawa sinabi, meron akong 30 dB na noise factor dun sa ano natin, dun sa signal. So kaya kong tanggalin yung 30 dB na yon at ibalik yung signal natin dun sa signal na inano natin, na ipinadala. So yun yung noise threshold na tinatawag. So we have at least, again, we have two formulas depending on the reference on power that you have. One is in watt, dB watt, and one is in dB milliwatt. So in dB milliwatt, you could have the noise threshold is equals to the 10 log of KTB. Ano na nga itong KTB, anak? KTB, saan nyo to nakita? Kay Sir Leo to, tama?
Yes po.
Oh, saan, anong formula to? This
Noise
is the
power.
formula, noise
Noise power po.
formula. Tama, very good. That is a noise formula, KTB. So, wag nyo kakalimutan si KTB kasi si KTB laging lumalabas sa board exam. Ang formula ng noise is always appearing on the board examination. So, kaya sa yung KTB na yan, wag nyo kakalimutan. Okay? So, what we have here is noise threshold is equals to K, 10 log of KTB plus noise factor in dB. Or you could have negative 204 plus 10 log of B. Eh, sir, saan nakuha yung 204? Ito lang po yung minultiply mo yung temperature na normal temperature which is 27 degrees multiply it by your case constant plus the noise factor that you have. So, pwede na yun. Inihiwalay lang po yung 10 log of KT plus 10 log of B. Yan lang yan. Kaya nakuha na nila agad yung negative 204. Okay? If you're going to use a milliwatt, all you need to do is divide your KTB in 1 milliwatt. Sorry, merong ano. Ay, si Nico. Okay. Okay, let's move back sa ating ano. So, all you need to do is divide your KTB in 1 milliwatt plus your noise factor which is in dB. Okay, so all you need to do and we will get this formulas. So, depende, sabi ko nga sa inyo, depende lang po yun saan, sa reference ng power nyo. Kung ano yung reference power. Tandaan nyo anak, yung 10 log of a certain power, halimbawa 10 volts for example, this is the 10 watts for example, this is just what we call the formula for dB, yung 10 log of your power. Kaya lagi nyo makikita si 10 log of power, 10 log of power. Okay? So next we have here the paid margin or the improvement threshold. The paid margin is the point where capture effect takes place and the output of the signal to noise ratio suddenly jumps to 30 dB. Halimbawa, na-receive na natin yung signal. Tapos pagkayari nun, biglang papataasin ni receiver yung ating na-receive na signal, yung capture effect. Kung ano yung na-capture na signal natin, patataasin niya sa 30 dB para makita natin ngayon, kumbaga, yung maliit na signal nyo, i-jump niya agad. Ang mangyayari dyan, ganito. So, whatever signal is received from your receiver, halimbawa, meron kang receive signal dito sa isang area, na-receive mo ganito kalaki. Ayan. So, ang gagawin ni receiver, i-jump niya agad yan sa 30 dB. Palalakihin niya agad. Bakit sir palalakihin? Para makita mo agad kung ano yung signal mo at saka makita mo yung noise mo. Dito kasi makikita yung signal to noise ratio natin kasi makikita mo na agad yung anong itsura ng signal mo. Kasi pinalaki niya lang. Kung kahit na may noise yan, palalakihin niya kasama yung noise. So, dun yung ginagawa sa paid margin or improvement threshold na sinasabi. So, in the improvement threshold, you have here the formula, noise in dBW plus 10 dB. So, in-add niya lang. Nag-add lang tayo ng 10 dB to jump up your signal into 30 dB signal. Next, we have here the receiver parameter, which is the carrier to noise ratio. The ratio of the minimum wideband carrier at the input to a receiver that will provide a usable baseband output to the wideband noise present at the input of the receiver. The noise introduced within the receiver, the noise sensitivity of the baseband detector. So, ang yung signal natin, signal carrier to noise ratio lang natin, gaano kalaki yung signal natin at gaano kalaki yung ratio ng noise na meron tayo dun sa na-receive na signal. Bakit kailangan ito? Kasi tinitingnan to kung kaya pa ba nung sensitivity ng baseband detector natin. Yung baseband detector mo is yung nagdi-detect nung signal mo dun sa noise na meron tayo. Ay, sorry. So, halimbawa, meron ka dito, tapos meron tong tawag dyan, noise. Ayan. Halimbawa, may noise. Ito kasi yung baseband mo. So, chine-check nung sensitivity nung baseband detector natin kung kaya niya pa bang ibalik ito dun sa makinis or matinong signal na meron ka. So, chine-check natin. Kaya niya kinukuha kung gaano kalaki yung noise na meron dun sa signal na dumating. So, the formula for signal to noise ratio is equals to your RSL or received signal level minus your noise. So, this is in dB. So, tandaan nyo na naman ito. Dapat yung signal, received signal level nyo is in dBm. Tapos, yung ating noise is in dB para makakuha kayo ng signal na in dB. Signal to noise ratio in dB. Okay. So sa AM daw natin, signal to noise ratio is also carrier to noise ratio is equals to signal to noise ratio. Pag FM naman natin, signal to noise ratio is about 30 dB larger to your carrier to noise ratio. Okay? Next, we have here the paid margin. The paid margin is a pudge factor included in the system gain equation that consider the ideal and less predictable characteristic of the radio wave propagation such as multipath propagation and terrain sensitivity. So we have different, when we talk about paid margin, paano tawag dito? Dito kasi masasabi kung hanggang saan lang aabot yung signal mo. Kaya siya paid margin. So kinukompute natin lahat ng factors affecting your signal. Specifically, yung terrain at saka yung atmospheric condition. So, we have different formulas. In terms of your received signal level and improvement threshold, we have paid margin is equals to RSL in dBW minus improvement threshold in dBW. Wait lang ha, yung nag-message. Okay, so such multipath propagation and terrain sensitivity. So we have here FM in dB is equals to RSL in dB. This time we are just going to use dBm. So dBm minus dBm, you got dBm here as your paid margin. So RSL in dBm minus the improvement threshold in dBm is equals to paid margin in dBm. So another, in terms of your propagation parameters, kung lahat po ay pag-uusapan natin, ito po yung talagang formula ng paid margin nyo. Medyo mahaba to. Wait lang, merong nag-ano. Okay, so we have here the formula for paid margin is, sorry, umakyat na siya. Ito pa. Okay. The formula for your paid margin is, paid margin in dB is equals to 30 log of D. So yung D dito, anak, is yung distance between your transmitter to your receiver plus 10 log of 6 ABF. Yung AB natin is your surface factor. Ito yung terrain na meron ka. Yung terrain, ibig sabihin nito, ano yung itsura nung dadaanan mong lugar? Ito ba'y bulubundukin? Ito ba'y disyerto? Ito ba'y may tubig? Ito ba ay may tawag dito? Ma-building. So lahat yon ay kino-consider. Yung A natin na sinasabi dito sa 10 log of 6 ABF, yung A nyo is a surface factor. For a very smooth terrain over water and desert, we have 4 as your A. If you are an average terrain with some roughness, we have 1. And if you are for mountainous and very rough and very dry terrain, you got 0.25 as A. For a climate naman, this is the B. If you are is hot and humid in coastal area, you got 0.5 as B. And for normal interior temperature, we have 0.25 as your B here in your formula. Or for a mountainous or very dry but not reflective terrain, you have at least 0.125. Yan yung dalawang consideration when we talk about the formula for propagation parameters natin. So, ginagamit po ito pag ang formula nyo ay yung pag pinag-uusapan na yung terrain at saka yung atmospheric condition ng inyong lugar. So, the paid margin is 30 log of dB in kilometer plus 10 log of 6 multiplied by a quantity AB. Your A is a quantity of a surface factor. Your B is a quantity of your climate factor. Multiply it by the frequency that you're going to use at the receiver end. So this is in gigahertz minus 10 log of 1 minus R minus 70. So yung R natin is reliability factor natin. So here, or you could use the Rayleigh table for paid margin wherein sa 90% reliability factor natin, ang required paid margin mo ay 8 dB. If you're going to use a 99% reliability factor, you could use 18 dB as your paid margin. If you're going to use 99.9, you have 28 dB as your paid margin. If you have 99.999, you have 38 dB. As you can see, it is increasing by 10, depending on the number of 9 that you have at the end. So, yan. So, ito na po ang pinakamaganda natin. Yung 99.9999% of reliability. I think this is just around the 30 hours ng output or walang signal sa loob ng isang taon. So, 365 days times mo ng 24 hours. So, yun yung normal na natin. So, yung 99.99999, you have at least 30 hours outage. Ibig sabihin, nawawalan yung signal mo sa loob ng isang taon ng at least 30 hours lang. Maximum na yun. Ay mas mababa pa yata, parang nasa 20 to 30 hours lang yan. So, dapat daw ang paid margin natin doon is, required paid margin natin doon is around 58 dB. So, at least dapat yung signal mo is around 58 dB para maano natin na makare-receive pa rin ng matino yung signal mo dun sa kabilang dulo. So I think this is the last part of this, but I'm going to give a serious, what do you call this one? Serious problem here next time. I need to prepare for my second, meron kasi kung meeting mamayang alas 9. So I think I'm going to end it here at around 8:45. So I hope that you're going to make sure to read. The next topic is about the what do you call this one? Sensitivity and reliability computation ng ating system. So, and after that, we're going to move to the different what do you call devices for microwave communication. So make sure to read again because I'm going to call somebody again next time on this matter. So we're going to see again on Wednesday, and make sure to read. I'm going to give a discussion on the sensitivity. Sorry, let me see. The wave propagation. I'm going to start with the wave propagation and the system reliability. Yan. System reliability ang natin, topic pa. Tsaka yung mga diversity. Okay? Reliability and diversity, we're going to talk about that. And then afterwards, we're going to talk about the different devices that we're using on your on the system. So that's it for now. Let me see. Yung mga